Good day math learners, today we will have our video lesson for a new topic. I hope that you are all fine at your homes, together with your parents and other family members. Kindly read our content and performance standards, for you to be guided on what you should do and what is expected of you after this video lesson. We now have a little review of our previous video lesson. I will give you flash questions, then for 10 seconds, you must have your answers. Okay, let's start.
Which of the following is the tangent line?
Warm-up question number 2. Based on the figure given and your answer in question number 1, how did you identify the tangent line? Warm-up question number 3. What is an intercepted arc? If two tangents that intersect at a point are drawn, what will it form? Are you familiar now with tangent line and intercepted arc? I know you are. So, let's begin with our lesson. Are you excited? If two tangents that intersect at a point are drawn on, what will be formed? It will form an angle. Today we are going to discuss angles formed by intersecting tangents. The learning competency of our lesson is to find the measure of angles formed by intersecting tangents.
Do you have any idea on how to find the measure of the angle formed by two tangents? In finding the measure of the angle formed by intersecting tangents, we will apply the theorem involving angles formed by tangents. The theorem states that if two tangents intersect in the exterior of a circle, then the measure is 1/2 the positive difference of the measures of the intercepted arcs. For example, look at the given illustration. What is the name of the angle formed by two tangents? It is angle F or angle EFG. How about the names of the arcs intercepted by the angle? The arcs intercepted by the angle are arc EHG and arc EG. So, to find the measure of angle EFG, you have to get the 1/2 of the positive difference of the measures of arc EHG and arc EG. In symbol, it is shown below the illustration. Now let's apply the theorem on angles formed by two tangents with the given examples. Again, the theorem states that if two tangents intersect in the exterior of a circle, then the measure is 1/2 the positive difference of the measures of the intercepted arcs. So, let's have example number 1. In the figure, line segments K and M are tangents intersecting at point L. If the degree measure of arc KJM is 220, what is the degree measure of angle KLM? Solving the problem, let us first identify our given data. What are the intercepted arcs of angle KLM? You are right. The intercepted arcs are arc KJM and arc KM. What is the degree measure of arc KJM? Correct. It is 220 degrees. How about the degree measure of arc KM? How do we find its measure? You're absolutely right. To find the measure of arc KM, subtract the measure of arc KJM from 360 degrees, which is the measure of the circle. So, arc KM is equal to 360 degrees minus the degree measure of KJM. So we write, arc KM is equal to 360 degrees minus 220 degrees. Therefore, the degree measure of arc KM is 140. Now, to find the measure of angle KLM, we write measure of angle KLM equals 1/2 times the quantity degree measure of arc KJM minus the degree measure of arc KM. Substituting the given data, we have measure of angle KLM is equal to 1/2 times the quantity 220 degrees minus 140 degrees. Measure of angle KLM equals 1/2 times the quantity 80. Therefore, the degree measure of angle KLM is 40. Let us have another example, but this time, instead of finding the degree measure of the angle, we will look for the degree measure of one of the intercepted arc. So, take a look at the given illustration. I know that you already have an idea on how to find it. But let us try to solve it together. In the given example, we are finding the value of x, where x is one of the arc, intercepted by the angle whose measure is 11 degrees. Now, how to find the value of x? First, we will assume that x is the minor arc and 360 degrees minus x is the major arc. Writing as an equation we have 11 degrees equals 1/2 times open bracket, open parenthesis 360 degrees minus x close parenthesis minus x close bracket. Simplifying the equation, we have 11 degrees equals 1/2 times the quantity 360 degrees minus 2x. Multiplying both sides by the denominator 2, we then have 22 degrees equals 360 degrees minus 2x. Subtracting 360 degrees to both sides of the equation, we now have 22 degrees minus 360 degrees equals negative 2x. Simplifying the equation, we should get negative 338 equals negative 2x, then dividing negative 2 to both sides of the equation. We now have x is equal to 169, therefore, the value of x is 169.
This time, I will give 3 exercises for you to practice. In each problem you will be given 2 minutes to solve, and in each problem I will show you the solutions and correct answers for you to compare your work. Good luck, math learners. Let's start. If you got all items correctly, very good. You're doing well. Now, if we are going to apply the topic into a practical application, think of this. How can finding the measure of angles formed by intersecting tangents help you in your daily activities? I know you have a lot of answers for this question in your minds, and it's a very good thing. Keep doing so. This time let's go back with the key concept of our lesson. May I see if you have remembered it? Based on the examples and the activity that we have, how will you find the measure of an angle formed by two tangents? Yes, very good math learners, if two tangents intersect in the exterior of a circle, then the measure is 1/2 the positive difference of the measures of the intercepted arcs. Now let us test your new learned skills. Try to answer the following questions at your own convenience and refer your answers on further slides. I will also leave you with an assignment, to further guide your new learned skills in mathematics, and I am hoping that in the next video lesson, these new skills will help you learn more, safely in your homes, so keep on practicing, stay at home and stay safe. Goodbye everyone and have a great day. God bless.